Okay, I thought I'd show one more video to make a similar point that I made in other videos, which was how can we create different interfaces to edit XML files or provide ways for edits that people make to eventually migrate their way back to where we ultimately need to store them in an XML file. So one thing I've been thinking about is like we have a lot of texts that are pretty good transcription, but they need corrections. So one workflow I've got going here is that I've asked an agent to run over a given file and create candidates of lines in XML files that need to be changed. Okay. And so we've had an agent run through that and creates a JSON file like this to record a lot of information that will help us apply those changes back into the XML file without error, right? So we have old XML, new XML, old text, new text, what the issue is, and the decision that an editor has ultimately made. All right. So once this JSON file is created, we can create a little UI for this. Okay. And we have now I have 7 new files that don't have any decisions, and we can just work our way through those files. So I'll just start here. And in this environment, we get the line that's created. We get the old text. I can view what that XML line looked like. I view what the suggestion looks like. Here I can either accept it as is, mark it as this really is this way, or I can modify it. So let's just do these 3 together. We can see that the machine transcriptions was paired destinatus right here, but that's not right. And the computer suggestion, this is a suggestion from Claude, is much better. So I'll just accept it with an A. Good. And verum tamen, we can see corrupted there, much better machine suggestion. And predestinatio, again, predestinatio. So the machine doesn't like that word, but that's really what it is. So here's where I'd press S for sick. Okay. And this is going to create a modified suggestion, which I'll save like that. All right, those 3 are done. Let's go to the next file. Secundo, we can see that this wraps the line. So actually, we have a more complicated case. We actually want to modify this, but then leave a note, right? So what we can do is leave it like this, and then we're going to do double slash. Anything that has a double slash at the end, when the changes are applied, this tells the LLM we can't just automatically make these changes. We need to think about it and make the changes. So um, review line break. So we would expect the machine to go over that and combine those 2 lines, and we'll see how that goes. Next. Hick, that looks good. Errors here, but we want that like that. There was only one there. Let's go to the next one. Pre-allegatum, much better. So the best case scenario is where we just have obvious fixes and we just keep hitting A. Here it's significato. Looks correct. Good. Non-correct. Quam. This is an odd one. Actually correct because it looks like a misprint, so we'll do sick and objectum and objectum. Here we have a mistake in both the suggestion and the original, so we're going to do a modify, and we're going to go with parentheses there, and we'll hit enter to save. Objectum, that's what we want, easy. Substracti, that's really a misprint, so we'll say sick. Eadem. Here we'll leave this as it is. So we'll reject that change. Next page. Subditi looks good. We'll take that. The computer didn't like the spelling, but we're going to keep that spelling, so we're going to reject that change. Subditis, good. We're going to accept that change. Here it doesn't like the spelling, but that's what we have, so we're going to hit sick. Serwi is correct, so we're going to accept that. Habitur. Uh, this is an odd one. This looks like an odd misprint of a spelling. Habitur. Habiter is not really right either. I think this one's so odd that we'll give the reading the benefit of the doubt and accept habitur. Vetigalia is what we really have, so that's sick. Magus, accept. Professio, accept. Complexity, accept. Good. Two more files. This image is not available, so we'll just skip these. That's an obvious correction, so we'll take that. And we'll keep going. And we want the accusative form here, so we're going to modify that. Out is what we want. Constants, correct. Secundum, correct. Ille, correct. Here we have a needs line break review. Actually, we're going to reject this. Our line break's not lining up. So checked. Transmutabilia looks good. Consequentes, we'll take that. Okay, so we've done all 7 files, and now we'll go back to our text here, and we say, now that we've made these changes, okay, we'll say, please apply these changes. And now it's going to try, for all the ones that we accepted, it's going to do an automatic line replacement. Anything that we modified, it's going to try to do that automatically first. And then if there's a token mismatch, or if we've done that double slash, then an LLM is going to apply that change manually, inspect each case, and decide on what the best solution is. When it's done, it's going to submit a pull request for each file changed, and we'll be able to review the pull request. So we'll just see how long this takes. Okay, we can see that it made 8 different pull requests there. After making those pull requests, now it's trying to apply any case where we modify, because those need closer inspection. It's adding second commits for those. Here we have one where it says 1 item for review. That's because we put the slash review line break, so it's going to have to review, it's going to review that. Hopefully it decides to connect the word crossing the line here. Take a closer look at what it's doing here. Okay, now we had it create, even though we have 7 pull requests, we've had it create a single file with combined pull requests, so I can see and inspect all the changes that have been made. So that's very handy. These all look really good. And that's kind of our issue is how do we create an environment that makes it easier for people to correct something without having them to ask them to really understand the XML structure. But at the same time, how do we reliably get those changes into the XML structure? And that's kind of what we're achieving here. We want to see that one line break, whether it worked as we intended or not. Here we've highlighted anyone that had a manual fix in yellow so that I know to look for it. And it's pretty close to what we want, except that well, it's what we wanted, except that sort of want the computer to recognize that we should bring this, say, there. Let's take a look at this just in GitHub. Interesting that, I mean, in a way it looks corrected because the text didn't even have say where it was before. So this makes me think we should check actually what that looked like. Yes, it's good. So that's a major improvement. Even though, later we'll want to bring the SE there, that can all be done automatically because we have the break equals no. So that's all nice and good. And so now that we reviewed all these pull requests, we'll say, wrong one. We'll say all these pull PRs look good. You can merge them. All right, so that's basically the point here, but we'll do this again for another 10 files, or we can run this for on hundreds of files at once to generate candidate files. Right? Then we can let non-XML users view the lines, view the corrections, make the corrections, save those in a JSON file like this, and then we can then an XML user and an LLM agent can apply those back and quickly review the pull requests. And this seems like an efficient way to really start correcting small errors really quickly. So we'll just start the workflow for the next. Let's start the workflow for the next 10 files. And we're going to repeat this process. It's going to flag all of the possible errors for 10 files, and it's going to suggest corrections to those 10 files, and then we'll load them in the UI viewer, and we'll repeat that process. All right, that's it for now. I just wanted to give you a sense of that demo. Thanks for watching. Let me know if you have any questions, use the comments, or send me an email. Thanks so much.